I work in the mobile devices group at Microsoft. My name's David Turner, and the area that I focus on in particular is mobility standards. So most of my job is focused on what's coming 2 to 3 years down the line. What are the technologies that are going to be going into not the next version of the product that you guys will see, but generally 2 products ahead of that if we're lucky, depending on what they are. So it seemed appropriate that I'd be one to give this particular presentation. Unfortunately, I had a couple strikes against me. One of them is it's the end of the conference, and so you've already had 3 days of people telling you all the cool things that are going to be coming. But on top of that, there was a great presentation given by Michael King from the Gartner Group earlier this morning. Did anyone sit in on that presentation? Oh, only a few of you. Well, that's good. So there won't be quite as much. Not so many of you will be hearing some repeated information. But luckily, I knew about that in advance, and so I tried to take a slightly different tack on things. And I decided I wanted to focus on more what's let me try to describe it. Where are things going, but tying it back to what can already be done today. One of the things I find very interesting about the mobile space right now is that the really cool stuff that we'll be able to do is right on the threshold. But yeah, there's some big changes still to come in terms of technology and the like, but you know, we're just this far away to be able to build some very, very cool types of applications end to end that involve and integrate, you know, all the way from mobile devices to desktop machines and so on. So that's really the area, that's the focus I decided to take on this presentation. And I definitely will be talking about new technologies and sort of what's coming. The first 2 points there, economic trends, what are operators looking for, go over those briefly. I'm going to set the context in terms of what is possible today, partly to emphasize that there's actually more you can do today than you might realize, that we have more of the pieces in place to build some very sophisticated solutions. And then from there I'll lead to, you know, what do we see coming and what kind of environment do we see going forward. So as it's the 3rd day of the conference, is there anybody here who, first off, hasn't seen this slide or one like it, and who isn't convinced that there's just tons and tons of opportunity ahead of them? Is there anyone that thinks this is a dead market? Probably not. Okay, so we all know, yep, lots and lots of cell phones, lots and lots of new apps, they're becoming more and more capable, great. We've got tons of opportunity, so we can accept that one. What excites the mobile operator? The mobile operators live in a world of transaction-based billing, right? Per minute, per this, per that. And even though they have these packages of so many minutes, unlimited minutes and carry forward minutes and anytime minutes and whatever they're called, they're still primarily based on a transaction or value-based services model. And so to the extent that you can build applications that extend that model, you're going to make the operators happy, and your application is going to be very compelling to the mobile operators. So the internet model is very much one of all you can eat, right? You pay a fee for your ISP, and boom, you can just access it, and you generally can use as much as you want. Even the hotspot services now are generally based on time. You can do as much as you want during that time, but it's generally an unlimited type of access. The different model that the operators like is one where the charge is based on the value to the customer. So sending a single text message might be worth $10 if that message happens to warn somebody about a nuclear plant meltdown or something in time, or something else that's important. On the other hand, if it's just spam mail, or if it's news articles that are really just rebroadcasts of content available anywhere else, it may be higher volumes of data, but the value is going to be low because you can get them from other places. And those are sort of extreme examples, but the focus on discrete transactions and charging by the value of the transaction over the size or duration of the transaction is really what gets the operators going. And then related to that, anything that adds value to the operator's network. The operators are facing 2 big problems these days. I mean, they've been facing the problem of churn for a while, but That was made worse recently with the new laws that now allow you to carry your phone number from one operator to another. How many people here have switched operators since that law was put into place? Wow, not many. Surprised. I would have expected more. I know for myself, it kept me with one particular operator longer than I would have liked. It was before the law came into place, because I didn't like the carrier. I was very unhappy with it, but everyone knew my phone number, and I didn't want to switch. Now that I can take the number with me, the barrier to switching is significantly lower. So the operators are desperate to find ways to keep people using their particular network, to build brand loyalty, to build network loyalty, and prevents people's inclination to just jump over to another carrier, at will. The evolution of hardware these days is really quite interesting. It's too bad I just thought of it now, but I could have drawn a Venn diagram with all these little devices. Because the point is, every one of them does different things well. I mean, they all do most of the same things, but they're targeted at different environments, different user scenarios, different, in some cases, content, and the primary purpose of the devices varies as well. But they all tend to have bits and pieces that the others do. So you've got devices that are primarily focused on media, but could also be used for as a phone. You've got phones that can be used for media devices. You have computers that can be used as media devices, and with things like voice over IP, it can be used as a phone. You've got your TV now, which is clearly a media center, but can also be acting as access to the internet, and on and on. So even though we're getting this great diversity of types of hardware, there's actually a convergence going on in that they all tend to be able to share the same information or same types of information and communicate with one another. I can have my Xbox get information from my PC in order to show a slideshow. In fact, I did that at Christmas. More was experimenting than anything else. We had friends over to visit, and I had a nice new TV for Christmas. And so I downloaded a bunch of pictures I had taken of the neighbors, and we had a neighborhood party. And so I put the slideshow up, and it was fantastic. All I had to do was pick the files, and there's software that just streamed it over the Xbox, and it just ran in the background with some music playing while everyone was milling around, talking, and so on. And it was really quite slick, especially considering how easy it was to do that. Software, if you haven't heard this already this week, software is obviously what we see as the key enabler in this case. It's the software is what allows all of these devices to converge in terms of, again, the data use and the communications, that they can talk to each other, that they can share the information. Pardon me. Software is at the heart of all of that. So I'm going to show you a video now. Some of you may have seen it before, and actually I'll be asking about that later. But let me just show it. And it'll come back.
Finally, I get on the plane. When they make that announcement that you can't use your cell phone.
So I'll start it over.
Far be it from me.
How do I start it over? There we go.
Finally, I get on the plane. When they make that announcement that you can't use your cell phone, far be it from me to trifle with the FAA. And then I realized I couldn't make a call if I wanted to, because I left my smartphone plugged in and recharging at my house. Next time I am going to duct tape 2 alarm clocks to my head, rigged in series, forming a sort of Cray super alarm clock.
It's a good engineering joke.
How can I help you?
Anyway, my entire life is in that phone. My appointments, my contacts, my phone number. Well, obviously my phone number.
Do you have your smart card?
Yes.
Maybe we can get your life back.
Can you believe I left my phone at home?
It's a real shocker.
Sorry, dude. Sorry, dude. Call Dr. Andre now!
Dr. Andre's office.
Yes, hi. This is Steve Masters. I need help.
Just relax, Mr. Masters. Would you mind if I verify your identity?
Sure.
What happened this time, Mr. Masters?
Bike messenger? Don't ask.
I see this isn't your first encounter with a bike messenger. Oh, I see. You're in San Francisco. Now, do you have pain or swelling?
Both! And I'm a tad bit stressy. Sorry.
I can hear that. Do you need to go to the emergency room?
No, please.
Is there a clinic nearby?
That accepts my insurance?
Let me see if I can schedule something.
Good. Scheduling is good.
All right, Mr. Masters. You've got two choices. One, your managed care with 100% of your coverage has a clinic 30 minutes from you. Or your wife's Safety First plan has a clinic 2 blocks away and opening in 15 minutes, but you're only covered for up to 80%.
Good. 80%. Good.
Now, do you want to pay the remaining 20% out of your prepaid medical? You have $2,000 left.
Yeah, great, sure.
Can you approve Dr. Walu accessing your medical records? It will speed things up.
Sure. And can you send a car service? Like you did with my head?
Honey, it's on the way.
Nasty sprain, Steve. Bike messenger again, huh?
Yeah.
This is highly improbable.
Oh, took the words right out of my mouth, Dr. Walu.
Walu.
Walu? Sorry.
Yep. You have to stay on your toes in this city. I'm gonna prescribe you something for the pain.
Good.
Pharmacy next door, okay?
Great.
You're allergic to codeine, so I'm gonna prescribe Meperidine.
All right.
You know, I think I'm gonna give you morphine instead.
Morphine? Really?
Wow. Should be ready in about 15 minutes. Watch out for bike messengers.
Ah, good one, Dr. Walu. Walu.
I agree with Dr. Walu. It doesn't look like a break, so you should be fine.
Oh, that's good news.
Okay, thanks, Doc.
Oh, and Steve, be careful out there.
I'm being a lot more careful, I can tell you that. Oh.
Who's seen that video before? Wow, for a number of you. Surprised. Does anybody know when we made that video? 2000. You're a ringer. This was actually produced for, it was produced in 2000, and it was produced for an event called Forum 2000, which was the event where we announced our .NET initiative. That was the first time we publicly announced .NET as a brand and what it was all about. So as I was getting ready for this presentation, I stumbled across this video and thought it would be pretty interesting to show it because it sort of highlights not only what we see people doing with mobile technology, but what we were thinking about 4 years ago. Of course, those phones didn't exist. The tablet PC did not exist, and most of the screens you saw were all complete mock-ups. So while today it may look reasonable, most of what's there was completely faked. An interesting thing about technology, just quick aside, is that I love gadgets, love playing with them. I just bought myself a Bluetooth GPS thing, more toys. Got a Bluetooth headset here, which I'll show you in a bit. But my wife is really hard to impress. I show her this cool stuff, and her response is usually, well, isn't that what computers are supposed to do? Or, you mean they can't already do that? And it's a real, letdown. It just sort of pops my balloon sometimes, because I'm all excited, and she just sort of shrugs and thinks, well, isn't this possible? What's interesting about this video is that when I remember showing it to her one point, and I got this same response, and I went, no, but you don't understand, you see. And then I stopped, and I realized, wait a minute. Even 4 years ago, a lot of what was there was doable. Now, certainly not as much as is today, and I want to run through that. So the first thing we saw was him using his identity. Now, the particular mechanism he used of waving his card over the phone is clearly not how we're handling identity today, but you have your SIMs in your phones, and then you might have a USIM if it's a CDMA phone. But we already have this notion of a smart card in your phone, and it carries a secured form of ID. So, that part's there already, and in fact, with the smart card toolkits, you can even extend that functionality and use that ID for any number of things, like accessing corporate resources or using it for sign-on credentials for other things. Universal access to data. You got this bare-bones phone, put his credentials in it, and then immediately synchronized with a server somewhere or with a data store somewhere. Might have just been a desktop machine somewhere. And he pulled down all this data. Well, that can be done today. In fact, I do that on a regular basis with the various phones that I have. I've got 2 or 3 or whatever, and I use them for experimenting and testing new versions of ROS or testing new applications. And what it means is I'm often just completely reflashing them, wiping them clean, starting from scratch. And I've got things set now so that I've got a configuration file on the phone, so that pre-configures everything, including my link to the Exchange server. And I put the SIM card in, I hit sync, and all the relevant data comes down. And because I've got a convenient plan from T-Mobile, $20 a month, all you can eat, so to speak, unlimited GPS or GPRS service, then doesn't matter how much data there is to pull down. And the beauty of it is I can set it to sync and go off and do other things, and the stuff can be trickling down in the background. So I don't have to be tied to it. I can be walking around. And the nice thing is with the new suspend resume features in GPRS, if I get a call that comes in, it'll interrupt the data transfer, but then as soon as the call ends, it'll reconnect and it'll continue doing the data transfer. So while the speed may not be blazing, I got time, right? And once the bulk of the data is synced up, from then on, it's only going to be little chunks of data. So that whole idea of having just universal access to your data, regardless of what device you're using, is something we can do now as well. Voice-activated dialing, the number of ways of doing that. You've got software on the phone that you can do it with. You've got server-based dialing that a number of mobile operators offer now. We saw a couple of examples of presence and authentication. Right? He had to prove to the receptionist at the clinic that he was in fact Steve Masters, and at the same time he provided actually location information, skipping ahead here, telling her where he was, because that was important for her to know so she could offer additional services. We also saw integration of the phone system and the patient record system. By the fact that he called in, they were able to identify, of course, who he was and automatically called up his records. I already mentioned location. Integration with the insurance companies and approved clinics. And these things are very server-centric types of applications. But one of the things I want to emphasize is that that's as much a part of the mobile experience because it's all about getting access to data. It's all about having access to existing systems and integrating with existing systems. Building a mobile experience is not about building new systems. It's taking advantage of what you've already got and leveraging it in the best way possible for those people who are remote, let's say. We also saw authorization. So once he had proven who he was and they determined that he was going to go to Dr. Walu's clinic, he had to give his consent that his medical records be passed over to her. So what we saw there was not just an authorization, but also a form of identity federation, because what he was doing was giving his clinic permission to give those documents or give that information to the clinic in San Francisco. Again, when he asked her to send the car, that was also clearly a location-based service. So because of where his phone, whether it had built-in GPS, whether it was using assisted GPS, who knows, but somehow it was able to determine his location, which the receptionist was able to use perhaps in an automated fashion, perhaps just over the phone, to hire a car to come rescue Steve. I already mentioned again the authorized access to patient records. So there was the authorization process where Steve said, yes, you may do it, but then Dr. Walu, I always get it wrong, had to be able to use them. So again, there was this passing on or delegation of authority or, authorization, so that she was given the right to look at the records. And then we saw the real-time integration with the pharmacy. And a lot of these tend to be similar types of solutions. We're talking about integration of various systems. And clearly that's what Microsoft Platform is all about. That's what we're doing with .NET tools, with our servers, with the Windows server products, the desktops, and with the Windows mobile clients, is making sure that the various applications running on these different devices can all talk to each other so that you can actually build these integrated types of scenarios. And the last thing, most interesting of all, that in addition to being able to do all this, he was actually able to talk to another person. You can use these phones for that, you know. Has anyone showed you that this week, talking on them? Or has it all been music and videos and stuff? Oh, are we having a problem with the signal there, Michael? We need someone to call me in a minute. So I'm going to go off on a bit of a tangent here. Just to establish what mobility means and what it means when somebody says mobile. Typically, whoop. Is that you calling, Michael? Okay, don't need it yet. Thanks. Ignore. Mobile, right. People tend to think of mobile as meaning mobile phone. Their focus tends to be limited on that. And one of the things that I found, especially working in the standards area and working with operators and other handset manufacturers and even other telephone infrastructure manufacturers, is there's a need to change the thinking about mobility. And mobility is not about cell phones as, you know, these specific devices. There's some general concepts that are particularly important when talking about mobility. One is that they are frequently, although not always, resource constrained. And I think this is fairly well understood. Reduced processor speed, storage, battery power, and so on. You probably heard that many times this week. Clearly you're aware of that yourself. Battery power tends to be the biggest limitation still. That's the area where we're not advancing quite as quickly relative to some of these other technologies. It was interesting, Michael King from Gardner this morning was talking about battery technologies and fuel cells as being proposed as one of the types that could be used. And he commented he wasn't sure he liked the idea of an alcohol-based fuel cell riding around in his pocket. I thought, well, I'd probably have to agree with that. So anyway, but battery power is still going to be a limitation. And in fact, it's not just limited to small devices, is it? Right? Battery power is also a problem when you're carrying around your laptop. Now, given the larger size, there's opportunity for doing more interesting things with battery power there, but they still suffer from similar problems. Connectivity limitations is another key. High latency, low bandwidth, intermittent connections. This is also an area that's changing rapidly. Who here has got has an Edge card or has a device that is Edge capable? One. Interesting. Okay. How about the 1X, CDMA 1X? I forget what the rest of it is. One person. What's that? Right. Thank you. Only one. Surprised. Well, regardless, they're both much faster than we have today, than the GPRS is, and certainly using your phone as the voice line as a data line. So those connections are clearly improving. As I mentioned already, the GPRS connections have now the ability to suspend, resume when voice calls come along, and so that deals with some of the issues. But in the end, what you still are going to be facing is the intermittent connectivity issue, right? The fact that people have the devices, are walking around, just means that the connection cannot be counted upon 100% of the time. You can count on it as being there most of the time, but you have to understand and recognize that regardless of the type of wireless connectivity you're dealing with, there will always be reasons for people dropping their connection. Sometimes it's because they turn the things off. And that's something that has to be recognized when building applications. And the third one is the UI constraints. Now, not all devices have them, and it varies dramatically. I mean, you've seen a host of different types of devices this week, some very small, some medium, some larger, and also the different operating environments have an impact on how people use the devices. And as I'm sure you've seen with a lot of the speech server stuff this week, there's some very interesting innovation going on in what's called multimodal access. Now, true multimodal doesn't mean just using screen input or just using speech. It means using an appropriate hybrid of those different technologies. And with the advances we're already seeing in speech and even with handwriting technology, the UI constraints will always be there because a small screen is a small screen. You can only show so much information. But we're finding interesting ways of solving some of the access and usability issues. So given those three broad areas, which of these are mobile? So we've got a phone type thing, a smartphone, small form factor, clearly not as capable as a desktop, and today anyway, the connectivity is somewhat limited. And that'd be your smartphone or perhaps even Pocket PC Phone Edition, typical of that. Slightly larger, but still small form factor, more capable, but still not as capable as your desktop, a Pocket PC, say, with a Wi-Fi card. Well, all of a sudden, you've got great connectivity. Well, sorry, I should caution that. How many people here have had trouble with the wireless LAN? Yeah. So going back to my earlier point about not assuming you've got a permanent connection. Even wireless LAN, which tends to be, when it's not overloaded, a very reliable way of connecting, and now with 802.11g, quite high speed, it still goes up and down. People at home have problems with the microwave interrupting their Wi-Fi network or cordless phones even. But in general, you've got on the high end of quality of connection when you've got a Wi-Fi card. So the device isn't so powerful, but your connection is quite good. And then you get kind of a flip-flop. So you got your tablet PCs and other laptops, and those are a larger form factor. They tend to be very capable devices. But what if you have a GPRS card or an Edge card inside your device? Well, all of a sudden you're talking about high processing capability locally, but not a great connection, or at least no better than what you have with your cell phone. If I put a Wi-Fi card in, then I've got kind of the best of both worlds. I've got high-speed connectivity, and I've got lots of power locally. Just unplug this here. Just to show quickly here, here's an example of, I can see it too clearly. Oh, it's not in focus. Oh well, you can see it generally enough. This is a Wi-Fi card here stuck in the top. And so, when I've got this device connected to Wi-Fi, like in an environment here, then while the device is small, I actually have very good access to my email. And because I can access my exchange information over the web with the Outlook client in here, I actually have high-speed access to my mail. And I can do mail in real time on this device. And in fact, I do. Ooh, and I've lost my mobile signal. That's not good. Well, let's hope it comes back. So the point of highlighting those differences is I want to emphasize as you move forward and as you're starting to build new applications and look at new problems you can solve and how you want to go about solving them, the key is to build to what I'm generally calling a mobile model. And I didn't know what better word to use there, but build your apps thinking about those types of constraints that you have. Don't build the apps thinking about, is this going to be using a cellular connection? Is this going to be using a Wi-Fi connection? I mean, those definitely have an impact in the general, or if you know that there's going to be they may have impact short term, is what I'm trying to say. But in general, those things are improving fast enough that if you deal with the key issues of battery life and so on, well, actually, let me run through them. Be aware of your battery life. right? That's something you should be thinking about when you write your apps. Oh, I should go back to the screen. There we go. Thank you, Dave. Be aware of battery apps, or the battery consumption. I like to play games on my laptop on the airplane, and I downloaded a couple off the MSN Zone, and a couple of them were written very badly, so that even while they were idling, paused, my processing meter was running at full tilt. So it was just sucking down the battery power, even though I wasn't actively running the game. And I'm sure it was just some simple loop in the program that probably could have been paused or bypassed completely, but the fact is that the developer hadn't thought about that. They were assuming desktop users, they never took a look at that, and so it was a problem for me. Assume the connection can drop at any time, right? Build the apps designed for failure. Assume the network connection will fail. The problem with many apps today is that they're written assuming the network connection won't fail, and then when failure happens, they kind of muddle through how they deal with it. If you assume failure up front and account for it in the design of your messages or data exchange, you're going to have a much more robust application. You're going to have one that's going to recover more easily. You're generally going to produce a better user experience. And of course, you have to also assume, or pardon me, you can't assume how long an outage may happen. It could be milliseconds, it could be minutes, it could be hours. And again, these are issues that you need to think about when you're building your apps, because you need to wonder about things like state. Do I need to keep state on the server side for when the person reconnects? Can I assume that the state's being stored on the client side? Can I assume that the drop in connectivity is short enough that I don't need to worry about some of those issues? Don't know. Obviously, it's going to be dependent on what application you have or what application or scenario you're building to. But again, it's an important issue to be thinking about. Thinking about different UIs and how those are going to affect your applications. There's a presentation after this one, might even be in this room, maybe the next room, where it talks about resolution-independent apps. Right, with the Windows Mobile 2nd Edition, right, there's now the ability to have devices with different resolutions than the ones that we've had to date. So it's not just the sort of 320 by 240 by 320 by 240 resolution. You've got square screens. You've got people now going to landscape mode as opposed to the portrait mode. So it's important that when you're building an app, you give consideration to the types of devices that people may be using this app for. Clearly, there's going to be a distinction between something that is designed primarily for use on a laptop or something with a large screen versus something that's mobile or something that's in a smaller form factor. But you still, primarily when you're designing for smaller form factors, the key is not to focus on one form factor. You should look at your design so that there's some flexibility in the way the user interface is going to adapt based on the particular device that somebody is using. If you're building something that's got a protocol, if you're building that portion yourself, communicating between applications over the air, think about making that protocol and those messages what we call coarse-grained. You don't want to send big blobs over the air because you're more likely to get errors when you do that. And similarly, you don't want it to be chatty. You don't want it to be like a get-set property type interface that you normally have with say, a COM object. You want kind of an in-between state where you've got medium-sized objects and not too much traffic, because both extremes stress the system, increase the likelihood of failure, and obviously then impact on the user experience. Most importantly, and I think I said this already, don't commit to a particular wireless technology. As application developers, you should be looking at them as just another way to connect to the device. There are quite a few apps out there in the mobile space that are still tied to GPRS or CDMA or some particular type of wired technology or wireless, technology. And the problem is those things are changing fast enough, and the devices themselves are becoming more and more adaptive that if you pick one, you're likely to find that your app hits a roadblock sooner than you would like. So think about your apps, assuming that there's a wireless connection, assuming the various conditions that I mentioned before, but try and kind of just abstract out the notion of, well, which particular type of carrier is it? So I'm going to run through now a few technological changes that have been happening and will be happening. One of the more recent changes, maybe 6, 12 months, is this notion of always-on connectivity. So with, say, a GPRS connection, I am effectively online all the time now with this phone. And so I could have instant messaging on. And when I'm not on my laptop, I usually do log on to MSN so that I am with people using this. And again, as I said earlier, if a phone call comes in and interrupts things, it'll suspend the session. And when I finish the call, it'll resume the session, and I continue to be online. What's interesting is that the so-called worst case that we have today is almost like a dial-up experience, right? A slow dial-up, perhaps, but it's still in the same realm of dial-up that a lot of people are still using, heaven forbid, for accessing the web from home. Cost, of course, is still a limiting factor. There are some companies that are offering, some operators that are offering what I call all-you-can-eat packages, flat rate, unlimited access, but either it's at a slower speed. So, for example, the T-Mobile, for example, is GPRS speed and $20 a month, and the CDMA and the Edge stuff are both faster, but they're ranging $80 to $100 a month, which suddenly gets kind of pricey, right? You got to really want it. That's not consumer level costs. But the fact is, you can still get it. Multimodal interfaces. Pardon me. Again, I think you've seen a number of examples of that this week. I won't spend much time on that. Event-driven applications is an interesting one. Excuse me. With technologies like SMS, the phone is in a unique position in that it can be contacted. You can push information to that device, which is something that you generally don't get with the PC, especially if you're behind a firewall. Right? Somebody can't send you a message unless you're prepared to receive it. So if you've signed into an instant messaging app, like a Messenger or some such, then you've opened up a channel to the outside world and stuff can come in. But if you haven't done that, there's no way for someone from the outside to be able to ping you, so to speak, and get your attention. Well, they could through email, but beyond that, there's no way. There isn't an equivalent to, say, the SMS that you have with the phones. And what a lot of people are starting to do, including Microsoft, with our over-the-air syncing capability, is using SMS as a trigger. So that when new mail, say, comes into Exchange server, message gets sent to the phone, and tells the phone, you've got new messages. Notice I didn't say you got mail. And goes off and retrieves it from the Exchange server. So the user experience is one of pulling the data in real time, but in fact it's a push-pull type of scenario. What I realized that two ways I didn't put on the slide, of course, is IPv6 is another step in that direction that will enable similar types of capabilities, that will provide a channel for other systems to be able to connect to or contact a device in an asynchronous manner. True peer-to-peer, obviously that first ability to connect needs to be in place for a lot of the peer-to-peer stuff, but the types of scenarios you're seeing now on desktop machines and desktop-to-desktop will soon be available on mobile devices. There's work underway to make messaging systems true peer-to-peer. Today, most messaging systems go through a switchboard kind of thing to route the messages as opposed to handing them off so that the devices talk directly to each other. This is an interesting one. Multiple radios or receivers in a single device. Well, Bluetooth, GSM, CDMA, wireless LAN, right? Those are all things that we're all fairly used to. Digital broadcast is an interesting new one. But before I get there, let's see if I can do this now. I actually just experimented with this the other day. And I was truly impressed that this actually worked. So let me switch devices here. You ready there, Michael? So here's my machine. I'm supposed to be getting called. I've got a really tiny bar. Come on. Nope, there we go. Oh, lost it. I'm going to try again. Don't you just love demos? No luck? Tick, 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 tick. Darn it. Well, I'll keep yammering away and hope that it actually will connect in a moment. Had this demo been working, what I was hoping to show you here, let me actually do this one part of it here. So, nope. It's the hard way. There we go. Okay. So, unable to answer the call. Nope, you lie. All right. So now we can do this. So what you have, oh, I can hear myself. Could you put your phone on mute, Michael? It's freaking me out. So Michael at the back there just gave me a call. So what I've got right now is my phone on a GSM network, which is what received the call. I'm using a Bluetooth headset to talk through the phone. It's how I answered it, and it's how the sound's going back and forth, both my speech and the mic and speaker. And now I've got, as I pointed earlier, a Wi-Fi card up here at the top. And let me go to Google. And let me look for MDC 2004. And I'm browsing the web at the same time. So I've got 3 different radio stacks in this one device, all working simultaneously. I'm a hard one to impress, and I thought this was really cool. Mind you, there is a drawback. Anyone guess what the drawback is? Battery power. It's just sucking it dry right now. I made sure it was charging over here the whole time, but it, as you can well imagine, just drains the battery at an alarming rate when you've got all 3 of them going at once. Thanks, Michael. But anyway, I really just wanted to sort of show that, you know, we've already got these things working together. And the one that you may or may not have seen or heard about is this idea of digital broadcast. Putting a digital broadcast receiver into a mobile portable device. Now, digital broadcasting, whether audio or video, is not big in North America. And when I mean broadcast, I don't mean over cable or satellite. I mean, you know, traditional broadcast. Just, you know, blast it out through the airwaves, put up an antenna, and catch it kind of broadcast, like you have today with, you know, normal network stations and your AM, FM radio and the like, except sending digital audio or digital video signals. In Europe, on the other hand, this has already taken off in a very big way. And so there are actually already trials underway, including some being done by Microsoft, to use the broadcast channels as a downlink to your device, and using your mobile connection, whether it's a GSM or, well, if it's Europe, it's probably GSM, but, or even a wireless LAN connection as the control channel and back channel, so that you can use your device to look for content. Maybe it's a baseball game, maybe it's a football game, you know, maybe it's a cricket game in Europe, and you decide, yes, that's the one I want to watch, and you make the purchase, and when the game starts, presumably you'll have already been given the necessary credentials or certificates you need to unlock and view the content, because it's being pumped out in the air, right? It's just out there. They're broadcasting. And the beauty of it is that the bandwidth isn't affected by the number of people who are trying to consume the information, right? They send out one signal, and it doesn't matter if it's one person listening or 1 million people listening. They can use the same channel and pump out the same amount of data. Of course, the same isn't true when you try and do multicasting over their IP networks, right? The more people you have trying to tune in, then clearly the more load you're putting on the system. So it's a very interesting approach to solving some of the high volume, high bandwidth content problems. And in fact, people are now looking a step further beyond just streaming, say, real-time comment, to also using it in what's known as like a carousel for downloading data. And so packets get sent in a sequence that's kind of never-ending, so that it doesn't matter at which point you start, you're going to start getting the data, and you keep getting all the packets until it hits the end. But it just never stops sending it around, so that it doesn't matter when you come into the loop, you can always be getting the data onto your system. So that's a really interesting sort of new avenue that we haven't seen today. Of course, the part that will make all of this even cooler is when we can switch from wireless LAN to WAN automatically. So I may be online doing something with my Wi-Fi card, and I leave the building, and of course the Wi-Fi network doesn't work anymore, and I don't want to drop the session that I'm in. Maybe I'm buying stuff on Amazon, or maybe I'm bidding like a fiend on eBay, and I don't want to lose where I am. It's almost the deadline. Well, it'd be nice if things just switched over automatically. I didn't lose my session at all, and things kept on going. In theory, you can do it now, but there are a lot of hiccups that can happen and make things a little more difficult. Push-to-talk and voice-over IP are probably two things you hear a lot about. Again, earlier today, Michael King from Gartner said that PTT, which is a common abbreviation for push-to-talk, PTT was MIA, meaning missing in action. And largely I have to agree with him. I know there's a lot of work going on right now in the Open Mobile Alliance, or OMA. It's one of the standards forums that I'm actively involved with, and the operators are pushing very hard to establish standards in this space so that that this kind of walkie-talkie, push-to-talk capability can be used on any kind of cell phone, not just the Nextel types. But it's, I think, a little bit longer in coming. Voice over IP, of course, is something that in many cases is already here. Now, there's still a lot of limitations. The performance isn't as great as people would like it to be, but it exists and it works. Excuse me. And as the cell connections, cell data channels improve, then voice over IP, of course, becomes a much more viable option. What's interesting is that regulatory issues, especially in North America, are as likely to impede this as anything else. The telco companies are quite concerned about voice over IP undermining their, in particular, local phone business, because the local phone business tends not to be a very profitable one. And they have to pay a tax of sorts to make sure that everyone has access to phone services. And so if now suddenly I'm using voice over IP with my cable connection, then I'm bypassing that system altogether. And the cable providers aren't paying any of that tax that the telephone carriers are. So there's current lobbying going on in DC right now to try and impose the same kinds of restrictions and taxes on voice over IP. So that'll be an interesting battle in the next year or two. Simultaneous voice and data. It's funny, when I first put this on the slide a couple weeks ago, I was thinking primarily in terms of something like my GPRS connection, where I could have it live and be talking at the same time. But when I was fiddling with the demo I just showed you, I realized I've got that already. With my Wi-Fi card, so if I'm sitting in a Starbucks, most of which have hotspots now, I can have a phone call, I can take a phone call or make a phone call and be browsing the web at the same time using this device. That's very cool. So while I put it on the slide thinking, okay, this is something that's coming, in a lot of applications, in a number of scenarios, it already exists today. And I think that's great. We've got a number of different wireless carriers or wireless network types coming. WiMAX, essentially Wi-Fi, but with a much larger radius. Who here has heard of mesh? Mesh technologies, mesh networking? A few. Simple idea is that every device is a router, so that you don't have a central access point that everyone's got to connect to in order to connect to the web. You have essentially the same notion that works on the internet in the large, where a signal can go pretty much any path to get from one person to another, and it could go halfway around the world just to get to the building across the street, depending on how routing tables have been set up. The idea of mesh is that every device that is IP capable is also an IP router, and so the very existence of this group of people in the room means that we now have a network available to us, and we could all either take advantage of one path out. We could be sharing data. There's all sorts of new scenarios that become possible. Definitely there's some privacy and security issues that need to be addressed, but the notion itself is really quite interesting. And I already talked about digital broadcast, not just in the sense of sending down the latest the current Seattle Mariners game or football game, but using it as a means for distributing digital content like software updates or new ringtones. That'd be a waste, but anyway. So, just to finishing up here, I didn't want to spend a lot of time talking about standards, because that tends to bore the hell out of people. But I do want to emphasize that most of the new things that are coming have standards as their underpinning. The voice over IP, the new networking technologies, pretty much all the things that I discussed, location-based services, all depend upon some level of standardization running underneath. And here I've got listed, sort of broken down into discrete areas, some of the different standards that are we see as being particularly important, and definitely that we're investing in a big way. And the reason these standards are so important is for the reason it says at the top, interoperability. Everyone's here because they're interested in the Microsoft development platform and Windows mobile devices and so on, which is fantastic, but at the same time, we know darn well that there's a lot of other devices out there that aren't running Microsoft software, but we still want them to be able to integrate with the same systems, to participate in the same ecosystems and join the same networks and communicate with the same people. And the only way in which that's going to happen is if the protocols in between the devices and the data formats that are used to communicate are the same. And so again, these are various specific areas that we're working on in standards forms to trying to achieve standardization to make the interoperability story much, much better. The goal is to make mobile space one with the internet. Who here was involved in doing WAP programming or wrote applications for WAP? Not too many of you. That's good. Good, because it means you didn't suffer the pain. WAP was an attempt to take the internet and make it different. There was this belief that the mobile space was different from the rest of the internet, and therefore they should do things differently. Yes, they had various constraints to deal with, but the fact is that by being different, they hindered their own adoption. The fact that they weren't interoperable amongst themselves made it worse, but WAP just missed the mark because it didn't get the fact that for these devices to be truly useful, they have to be able to integrate with the rest of the web. They have to be part of the internet just like any other device. As I said already, common data formats and protocols are really at the heart of that. That's the same thing that makes the internet successful, and therefore it's the same thing that will make mobile technology and mobile applications successful in the broader scheme of things. We're working on converged messaging. The mobile space created what's called MMS, multimedia messaging. It's like SMS, except it allows for graphics and so on. But it's very much, as I discussed earlier at the beginning of the presentation, a transaction-based type of mail system where you get billed for every single message. clearly that's not a model that fits with the internet model of email, and there's work underway to get those to converge. The last two areas that are bringing things together, service-based architecture and supported by, or not supported, but implemented using things like web services, so that you're moving away from tightly coupled systems where you have these tight proprietary links between things to a much more open way of communicating, again, using things like web services. So the last bit I'm going to go through is a couple of recent announcements, just to give you some idea of some of the things that are coming in the industry that are kind of neat. One is a Microsoft-specific announcement. At the Game Developer Conference that was going on this week as well, on Wednesday, we announced something called XNA, and very simply, it's what we're developing for the next generation of gaming platforms. And the goal is to make the development of games consistent and, consistent in terms of both the tools as well as communication, gaming experience across Windows, Xbox, and Windows mobile devices. Now, that doesn't mean that you're going to be able to run Halo on one of these devices next year. One is a time issue, but secondly, it's, that's not necessarily the goal. The goal really is to leverage the assets of each system to help the other. So tools will be common. Many of the development environments will be common, those sorts of things. And then the second announcement is one that we made early in the month. All the companies listed there, Microsoft, Nokia, Vodafone, the others, got together and have submitted an application to ICANN to create a new top-level domain. So .com, .org, .net, those are all top-level domains. And we've submitted an application for a new top-level domain for the mobile space. One of the challenges that people have faced is when they want to go to a particular site that they know of, but they want the content that's geared specifically for limited resource devices, I'll call it. Where did they go? Did they go to mobile.microsoft.com? Did they go to microsoft.com/mobile? There was never a consistent way of finding things. There was too many variations in the way that people implemented things and built them. And on top of that, there was no way to constrain the various protocols and data formats that were being used. It's sort of a free-for-all. And so the idea of this top-level mobile domain is to put some constraints on what gets used in the mobile space, so that, again, we can improve the user experience. You won't get as much variability or variance going on from one application to another or from one device to another. So, finish up. As you well know, devices are going to keep proliferating. You're going to get lots and lots of new devices coming out, doing new things, specializing in various ways, but leveraging the capabilities of other devices and other applications existing today. Mobile standards are now building on the internet standards, and that's a very important part of all of this. Think of mobile devices as communication devices. If you've got a portable device and it's not connected, then it's just a PDA or it's just a phone. But as soon as you can connect it to other people, to other applications, to data sources, then all of a sudden you've got a much more interesting experience. And the number of applications that you can start to build just grows rapidly. And of course, a key part of that is making sure that mobile devices are a well-integrated piece of the web, an endpoint on the web, you might think. And obviously, Microsoft is a software company, and we think, and we believe quite firmly, that software is at the heart of it, and software is what's going to make all of these various things possible. Thank you.